All right, last video for this section. The second major function of the lymphatic system is involved with immunity, with how the body fights infection. So by definition, immunity kind of states that it's the ability of an organism to withstand invasion from microorganisms, and essentially being able to defeat a smaller organism or infection, or sort of repel all borders kind of thing. The human body can prevent entry of pathogens or destroy them if they enter. Now, there are a lot of things. Skin is the first line of defense, and it's impossible for microbes to cross unless there's a break in it. And then you have openings to all the major organ systems, and that's an easy entryway as well. So we're going to start here first, and look, this is not a microbiology course, so we do very brief with this, but mechanical barriers, skin. Skin prevents the entrance of microorganisms or infection that can cross the body. And I loved this diagram. I got this out of a micro book. It's showing here sweat, low pH. Actually, skin is acidic. And you see the arrows, but one of the first barrier is skin. The other barrier is this thing called a mucous membrane. So here is the entry to the respiratory system, genital, urinary, digestion. They're all lined with a mucous membrane that is sticky, and it traps microbes, and it also has antibodies stored there. So that is the first line of defense. Like it says here, skin prevents entrance of microbes unless it's broken. And then every single body system that opens to the outside has a mucus layer. And it will trap microbes. There are antibodies there. That's what it's designed to do. Yet, yes, things still get inside. Chemical barriers. Interferon. If you have a virus-infected cell in your body, one of the and viruses have been popular as of late. A virus-infected cell releases something called interferon, and what it does, it makes cells around that particular cell produce proteins that prevent that virus from invading nearby cells. So it blocks replication of viruses in the surrounding cells to prevent that virus from entering the body. That's one of the mechanisms that our body uses to defend against viruses. Now, acidity, that usually kills anything. There are things that can survive acidity. They're very few, but they denature the proteins. They change their shapes. Acid kills just about anything. Like the stomach is acidic. Kidneys are technically acidic. Fever, an increase in body temperature. The microbes that make human beings sick, they love to grow at 98.6 degrees Fahrenheit. If you raise the temperature of that, it will disrupt their growth cycle. Fever is actually a good thing as long as it doesn't get too high. And there is a chemical, it's called cytokine interleukin 1. And I'll have to, if you want to look that up, it used to be called endogenous pyrogen. And it's something that is released in your body that causes fever. It causes the hypothalamus to reset body temperature. And that chemical is released in response to white cells engaging in microbes and infection. The inflammatory response is used to block. This is a good picture here. These are neutrophils. See, there's a break in the skin. Inflammation traps microbes with pressure in one area, and that's where histamine comes in. There are cells that cause histamine to leak from the capillaries. Heparin is an anticoagulant that brings more of these neutrophils to that area, and they start eating the microbes. So inflammation is also designed to prevent the spread of infection. Phagocytosis are cell eaters, which is what they're doing. You can see that. Neutrophils and monocytes. Monocytes are bigger. See the green microbes there? They're eating the bacteria. And so that's what phagocytosis is. And I did, at some point, I may not have in this class, but You can look at this up on YouTube, but there's a neutrophil chasing down a bacteria. There is cytokine interleukin 1 that raises body temperature. And now we're on to the last sort of part to this. So here we go. So pathogen attempts to gain interest in the body. First line of defense, mechanical barrier, skin and mucous membranes. Pathogen enters the body. Second line of defense, chemical inflammation, phagocytosis, fever. Yet there are some things that make it past all that. And then you have what is called the third line of defense, which is what is called specific immunity. Now, specific immunity is based on what are called foreign antigens, which that would be the invaders, the microorganisms that get inside a person's body. Foreign antigens are microbes or substances that cause an immune response. I apologize. All right. When a person gets exposed to a foreign antigen for the first time, either vaccination or you get it what is called naturally acquired immunity. You actually get sick. I got chicken pox as a kid. And this happened with me in chicken pox. You get what is called a primary immune response. That is first exposure to a foreign antigen. And the thing about that is it takes your body a while to get started with the first exposure. Cells have to differentiate, which takes time. It's called the lag time. And you get a pretty low response, and it takes a long time to get there. Secondary immune response. And what ends up happening after the primary response, your body will develop memory cells, and then it's ready for the second exposure. The secondary immune response is exposure to the same antigen for the second time. And that results in a much shorter lag time, and you get a much bigger response from what are called the B cells and T cells, the specific immunity cells. So here's this diagram. This time thing on the bottom is not great. That's fine. This says adaptive immune cells and antibodies. It's talking about B cells and T cells. But you can see right here, this represents the primary immune response. And in all actuality, this is about 3 weeks. And you can see here it peaked. And this is probably about I say 3 weeks. I bet that this right here would be 5 weeks. It peaks about week 3. It takes a long time. It depends sometimes, but it takes a long time to get going. But you can see on this scale over here, as far as the amount of numbers of cells, it doesn't get very high. If you've already had something or you've been immunized, this is the secondary response. See how quickly and how big the immune response is. And then it kind of tapers off like that after a while. But this is a matter of a day, 2 days. And that's why usually you don't get something twice. If you've been immunized for yellow fever, your odds are it's not going to make you sick. A lot of bad things. There's no more smallpox. But some of the things you get immunized for, they're lethal in 5 days. And so your body can't develop an immune response quick enough if you've never had it before or never been immunized. Whereas in this case, you can. So this is called the primary immune response, the first exposure to a foreign antigen. This is called the secondary immune response, which is the second exposure to the exact same antigen. And what are antigens? They are the foreign microbes or vaccines that would enter a person's body. Okay, there are 2 main mechanisms with this. Well, I showed you the first and the primary and secondary, but here are the 2 cell types that are involved. These are lymphocytes. Okay. Now the first one, it's called humoral immunity. And this is what would happen. A foreign invader gets in your blood. It's going to come in contact with the B cell lymphocyte. Those form in bone marrow like all cells do. Lag time, 7 to 21 days. What you get as a result of this first interaction, you get something called a plasma cell and a memory cell. Memory cells are stored in the lymphatic system for the second response. But this is what a plasma cell looks like. This is actually those little Golgi apparatuses. These are antibodies. Antibodies are Y-shaped. And see the very ends here? Those are the antigen receptors. That's what's going to bind to the microbe. And Plasma cells are antibody factories, and they are 20% of specific immunity. But once these form, and these antibodies, they're going to go back and they're only going to attack that specific antigen. They don't just randomly go around and attack everything. That's how a B cell works. See, this diagram has stem cell, and it's showing here are B cells, and then you can see, where is it? Oh, right there. So there's the antigen. See how they're coming in contact with these B cells, and this is that division. See, here are the memory cells. They're not involved with the interaction. They're stored for later. And this is the lag time part. See, they're the plasma cells, and they're the antibodies, and then they're going and they're attacking that antigen. That's 20% of specific immunity. When you hear the term titer, T-I-T-E-R, they're talking about the level of antibodies in a person's system. If you're going to be a nurse, you have to get vaccinated for hepatitis. It's a series of 3 vaccines. And if you've had them prior to applying for nursing school or needing them, you're going to have to go to the hospital. They'll draw your blood, and they'll check what's called your titer level for that particular, for hepatitis. Or if you've never had them before, this is what you're hoping to build up. These little memory cells and very specific cells. Now, here's the other part. This is 80% of the specific immunity. They're called T cells. Same thing. If they come in contact with a foreign invader, an antigen, lag time's the same. You get something called a sensitized T cell. That means it's very specific for this antigen. And then you also get memory cells as well. This is a virus-infected cell. It's having a bad day. It looks like it's been attacked by Indians. These are antibodies. See, there's the virus. This is a T cell, and there's different categories of these. This one's called a cytotoxic T-Cell. It goes up, it binds right here to a virus-infected cell, and it just tears a big giant hole in it. It does release little chemicals that help with that. But they're very confrontational. They don't produce antibodies. The whole thing attacks foreign invaders. And there are different categories. There is a helper T cell that helps the immune response, and it helps stimulate B cells. Memory T cells are the ones that are stored for later. They're not really involved in the first interaction. They get stored in the spleen, the liver, the spleen, the lymphatic organs, lymph nodes, all that kind of stuff. And then a cytotoxic T cell is what this guy here is. They go up, they attack foreign antigens, foreign invaders, and they destroy bacteria, viruses, fungi, and virus-infected cells. So they're involved in the primary and secondary immune response, but they directly attack foreign antigens. Okay. That is a little bit about immunity. I hope these videos help, and thanks for joining me.
And that's the bottom line, because Stone Cold